spotting any questioners. Yes, the gentleman there. Oh, sorry. Do we have a, yeah, we do.
Hi, Bruno Conti from ANCAP. Thank you very much for your presentation. I would like to know if Romania has any potential regarding unconventionals.
Sorry. Can we have the micro? Yeah. Well, we have conventional oil and gas production, and any petroleum system should have a source rock. We are not currently in any unconventional operation. However, our geologists are having their own opinion about it. What we found is that very often this unconventional is a little bit overrated, especially if you are talking about a basin which has been producing for such a long time. The source rock seems to be very deep. So we are talking about unconventional which should address source rock at more than 4,000 meters. Chevron is active in Romania. They are drilling right now their first exploration well, and they will take some cores and they will do an analysis in an area in which there are shallow prospects. But if I'm looking to the portfolio of opportunities, we have in the Black Sea a reservoir which has a permeability between 3 and 5 millidarcies. And in this reservoir, we managed to drill very long horizontal wells, multi-stage stimulated, and we got very nice oil production, and we have plans to expand that. So shale gas has a very emotional connotation. I believe that we have a lot to do in conventional, and we need to work very hard with the communities in order to explain them that what we do is engineering based and can be done safe.
Any more questions from the audience? There's a gentleman in the middle there.
My name is Javed Iqbal Jadoon. I'm from Mari Petroleum, Pakistan. You mentioned that you will be using the CO2 for the EOR. Is it possible, rather than going for the CO2, you just go for the nitrogen? You know that in case there is no bond, there is no cement bond, definitely I think that there will be a corrosion problem over there. So is it possible, rather than going for the CO2, we can go for the nitrogen pumping over there?
Practically, as far as the gas injection and EOR is concerned, as I have told that while we'll go for gas injection, practically what is happening, that that miscible gas will reduce the viscosity of that crude oil. Okay. In that way, CO2, N2 and hydrocarbon all can be used. It depends on the availability of the gas which is available for injection. In case you have CO2 for injection, it's fine. In case you have nitrogen, it's fine. There is a cost implication for the gas, individual gas, which is how much cost contribution will be there. But cost is not be very important unless you have the availability of both the gases. So what we have seen basically as far as ONGC is concerned, we do not have any easy source for getting nitrogen. At the same time for CO2 also. So we have started mainly with the gas injection. CO2 has not yet started. But in Canada and North America, they are flooded with CO2 gas injection. As I have told that it is not only from the availability of the gas is concerned, but also from the environmental point is concerned. So two factors are basically connected with this. All the gas injections will have the result, good result. Whether you have CO2 or N2, that is to be seen. And secondly, what is the cost coming for individual gas?
I think Gabriel wants to make a point.
Very short. So there are a number of experiments, and we did it as well. Nitrogen can be used in a half and puff, also type of scheme. So you inject nitrogen and then you lift the oil because you increase the pressure and the viscosity coming up. However, the source of nitrogen, it's the issue, to find a continuous source of nitrogen. There are cases in US where nitrogen has been used in order to frack wells. So that's also something which we have in mind. But to continuously inject nitrogen in order to sweep or to increase the decrease the viscosity of oil, it's not something which we have seen commercially possible.
Okay, any further questions? I just had one question. I was looking at your slides, the level of cost, the incremental cost in doing enhanced oil recovery, chemical flooding, or in situ combustion. These are $70 to $90 incremental cost was what you were talking about, compared with, say, a $90 to $100 cost of drilling a new well. These are obviously, the margin of profit and loss there is quite slim. I was wondering, what can be done to reduce the cost? Is this a question of lack of skilled resources, lack of engineers, or is it some other, is it energy itself that's the major barrier?
Yeah, the slide what I have shown basically, that cost versus individual technology. Definitely, the cost is having two impacts. One is the material itself, another is the procedure, how it is to be utilized. Okay, the material cost, again, it has got its own way, whether the cost can be reduced or not. I mean, the producers will not have any control about the cost of that particular material which is to be utilized. As far as the technology is concerned, yes, gradually now what I have seen in the world war scenario, that technology is coming in a better way so that the cost implication from the technical aspects can be reduced. But what exactly the cost can be reduced by adopting new technology, that has to be seen. What I have checked from ONGC's perspective, that microbial, which is shown MEOR, has a very long range of production versus cost implication. The cost as such is not changing very much, but the production enhancement is very large. So if by having the same cost also, if we can have more and more production availability, then even if the cost of production will be more, but practically the quantum of production will be very high. So that can offset the basically cost of production.
Thank you.
Regarding the thermal methods, there are basically two ways. In the thermal methods, one of the key parameters is how much steam you need to inject in order to get 1 barrel or 1 ton of oil back. And this ratio can go between 4 and 7, let's say, tons of steam for 1 ton of oil. And of course, less you inject and better you target, more efficient you are. That's one dimension. The second dimension is to generate steam cheaply. And here there are a number of experiments which have been done. I'm aware of the ones done in US to generate the steam with solar methods. Of course, this requires a balance because you need to invest in the facilities, the mirrors, and this requires maintenance. Some of the operators are hot housing these facilities, meaning that the boilers are completely covered. But all in California, this seems to work. There are still, if we're looking to the countries which have an old infrastructure like ours, we managed to increase the yield of our boilers from 30–40% to up to 60–70%. The other method which we have been applying with quite good success, it's whatever you have associated gas to use it in small cogeneration units and producing the same time electricity in steam. So I think, again, my message was the same. These are not very complicated actions, but they require a lot of people, a lot of attention, a lot of dedication and time.
Okay, thank you.
Solar UR has also come up. That is what we was just concentrating, that the steam can be generated through solar heating. So that is, I mean, in that way, very new technologies are coming up gradually, and which ultimately can give the benefit of.
Okay, well, I think I'm being gestured that I've got to close the shop, as it were. I'd like to thank Gabriel and Ashanendu for their interesting contributions to the EOR debate. And I'd also like to thank all our other speakers. It's been a fascinating day, and I think we've all learned a lot, and there's some interesting sessions coming on tomorrow, and I think there are drinks outside. I'll hand over.
Firstly, yes, thank you for all joining us. Firstly, I'd just say a big thank you to Carl for his moderation for today. If you'd like to join me in thanking Carl for taking on the role today. I'd like to join you now as my colleagues from the hotel come round and bring you around some drinks. We have our champagne round table sessions, moderated by some of our speakers and sponsors. Basically starting from the front and running to the back, we have 10 round tables on LNG partnerships, developing local content, mergers and acquisitions, finance and capital raising, downstream energy logistics, EOR, moderated by Mr. Mandal, who was just speaking, deep water and frontier, risk management and risk sharing, human capital, and shale and unconventionals. So if I could ask you to join the table you'd like, and my colleagues are